Good morning and welcome to a video on the rational root theorem. So you're often given a typical problem like this in Algebra 2 where it says to list all possible rational zeros and you're given a polynomial. And if you look at this polynomial, typically when you're finding rational zeros or x-intercepts, you factor the polynomial and you set the factors equal to 0 and you go on your merry way and you graph the function. But in this case, it's not possible really to factor this polynomial in any kind of traditional way that we've learned, right? So the question is, what do you do in this case? So your best bet in this case is to try to reverse engineer this problem. And I'm not actually going to even really use the theorem per se because it involves, like a formula to memorize, but I just want to sort of develop the intuition behind the theorem. Okay, so you want to say to yourself, all right, I have an x cubed, and if I had to reverse engineer and sort of take educated logical guesses as to what could have happened with the factors before this was multiplied out, I probably had 3 factors, right? And they probably all had an x in the front, right? Because if I were to multiply these 3 factors together, that's going to give me x cubed, okay? Then you want to say to yourself, what else could have happened? Well, do you guys see how I have the -6 here at the end? If I were to multiply out all of the numbers in each of these binomials, right? So if I multiplied these 2 numbers together, if I multiplied these 2 together here, right? Whatever that was, let's say that was 3, right? And then I took that and multiplied it here, I would have to get -6. So what I'm doing is trying to find numbers, right, that are factors of -6, that when I multiply these together, I get -6, because that's a logical guess as to what could have happened. So let's just make up stuff. So let's say I had +1, x minus 1, and +6, right? It is perfectly logical and possible that these 3 factors made up the polynomial. Now, I'm not 100% sure. I'd have to multiply it out and check. I may be wrong, but it's not illogical, right? Because 1 times -1 times +6 multiplied to -6. And it's possible, right, that if x plus 1 is a possible factor, then x equals -1 is a possible root. If x minus 1 is a possible factor, then x equals +1 is a possible root. X plus 6 is a possible factor, then x equals -6 is a possible root. Okay, but you may be thinking, wait, Mrs. Bailey, there's probably more options, and you're absolutely right. I could go on and on, right? I could have, I don't know, let's make some different numbers here. I could have x plus 3, x minus 2, x plus 1, because 3 times -2 times 1 multiply to -6. And again, if x plus 3 is a possible factor, then x equals -3 is a possible root. And so on, right? X equals 2 is a possible root. And so at some point you start to realize, wait a minute, I just need all of the factors of -6, and I will get all of the possible factors, and then I can get all of the possible roots. So to make a long story short, you have 1, -1, 2, -2, 3, -3, 6, -6 as your possible rational roots. Okay. Now, the question you may be asking is, how do you know if one of these possible rational roots is an actual rational root? And the question then becomes, well, we'd have to test it, and we'd have to use what's called synthetic division. Okay, so I think I'm going to make a separate video for that. So in the next video, what we're going to do is we're going to use synthetic division to test these possible rational roots to see which, if any, are zeros. And we may find that none of them are, but it'll be a good review of synthetic division.